74. In 74, we are given a function which is denoted by uppercase F, which is another mess. It's F of x multiplied by F of x multiplied by F of x. Horrible. Okay, one more time. Let me show you. So F of x times F of x times F of x. Then we are given a lot of information following that. We are told that f of 1 is 2, that f of 2 is 3, that f prime of 1 is 4, that f prime of 2 is 5, and f prime of 3 is 6. And the question is, find f prime of 1. So, okay, plug it in. And you will say, not so fast. So what do I have to determine first? Yes, so I have to find f prime. So, let's decompose this function. This is number 1, however, is a product. So that's my starting point if I decompose the function. This will be the second one, however, it's a product, another product. And then this will be my step 3. I know, terrible. But let's take it slowly. I have a function of another function. How do I differentiate a function of another function? I don't even look at this. I don't want to see it yet. Yes. So I have a function of another function. How do I differentiate that? There is no power rule. At least that is good. So I don't have to worry about it. So f of a function prime is f prime of this whole thing multiplied by this whole thing, what? Exactly. So whatever that is, and I'm going to copy it right now. So every time you see something weird like this, always take it slowly. And you should just cover it and think, okay, I'm differentiating a function of a function, so first I have to write f prime of that times the inner function prime. So now I copy x times f of x times f of x times f of x. I copy it here, x times f of x times f of x. Now this is done. No one can change that. But now I have to work on this. So I have to write equal. I copy this, x times f of x times f of x. So now let's see what we see here. Here's what I see. I see that I have to differentiate a product. This times something else. How do I differentiate this product? Let's open a bracket. And let me not close it because you know I always go over. So how do I differentiate this product? Don't even look at this. How do I differentiate this product? X prime, which is 1, times whatever, and I'm going to write it in a second, plus this times whatever I have here hidden, what? Prime. Now I stop and I fill it in. So let's see what I fill it in with. I fill it in with f of x times f of x. Now, this is done. There's nothing I can do here. Another piece that is done. But I have this one. I'm going to copy it for now and then decide what to do. Okay. I copy this and I copy this. So this is f prime of x times f of x times f of x. Okay. This is done. I open the bracket. I cannot do anything here. Plus, I must copy x outside. And now I say again, oh, I know what this is. It's again a product of two functions. This function and this function. So then, the first function prime times the second one. Plus the first function times, close this parenthesis and close the bracket. Okay, so this is my function. This is my function. So I'll write f prime, which is done. Oh, sorry. It's here, prime. All done. So this is the way we address weird functions like this one. So this goes with this, and this goes with this. You don't have to distribute, you cannot simplify, there is no need to do anything here. Now, I am ready to do what? I can figure out f prime of 1. Okay, so what is f prime of 1? Is f prime of 1 times f of 1 times f of 1. Bracket f of 1 times f of 1 plus 1 times f of 1 plus 1 times f prime of 1. Okay, ready? So f prime, 1 times this, so times f of f, 1 times this. Here, bracket f of x, f of 1, plus, there's no point in writing this, it's 1, plus f of 1, plus 1 times f prime of 1. And now let's see if we have everything. Oh, sorry. I forgot to put 1 in here. There is 1 in here. Okay. So I have to start from the inner in each and every one of them. So do I have f of 1? It's 2. So this piece, let me use this. This piece is 2. This piece is 2. This piece is 2. I'm going to write it one more time to avoid any confusion. So this is f prime of f of 2, bracket, f of 2 plus 2 plus f prime of 1. Not too bad when x is 1, right? Final step. Do I have f of 2? So then this piece is 3. This piece is 3. Do I have f prime of 1? 4. This piece is 4. One more step. F prime of 3, bracket, 3 plus 2 plus 4. 9, right? So this is 9 times f prime of 3. I hope to have f prime of 3. And I do, and it's 6. So then this is 9 times 6. Any questions? Any questions? I hope you bring more questions to class on Thursday. So let's move on to 3.5. Implicit differentiation. Implicit differentiation. So given f of x, I can find f prime of x, not implicitly, but directly. When we talk about implicit differentiation, we do not have f of x. We do not have, normally, we do not have f of x, comma, but an equation with f of x that mainly cannot be solved for f of x. Not always, right? With f of x, and I'll put in parentheses, that in general, we cannot solve for f, or it's too difficult to solve for x, if we can. In general, we cannot, or we don't want to, or it's too difficult, solve for f of x. We can still determine f prime, although we don't have it. So even in this situation, when we do not have f of x, but an equation with f of x, that's what we have, but an equation that has f of x, we can still find an expression for f prime of x. However, we will not use this notation for implicit differentiation, but what is the other notation that we will be using? Very good. We're not going to use f prime as a notation, although it's the same thing. And you'll see in a moment why. Let me choose an example. Let's start with a simple one. Here's the requirement. Find dy over dx by implicit differentiation. I'm going to say implicitly. And this is number 8, which is 2x cubed plus x squared y minus x y cubed equals 2. Two things here. Do you want to solve for y? Not in a million years. We can, but with a computer software. So no, we're not going to try. Okay. Second question I have. What does this mean? And yes, is the rate of change of y with respect to x. But what else it tells us? It tells us that y is a function of, say it louder, yeah. If it says dy over dx, what can it have in it? Of x. So we cannot treat y as a variable. Y is not a variable. Y is a function that depends on x. So here's how we proceed. Here's a question for you. If I have the equation x plus 2 equals x minus 3, or let's say 2x minus 3, can I subtract 2 from both sides? Of course. In the same way, we will differentiate both sides. We apply the same procedure, the same mechanism to both sides. Okay, the right-hand side is nice and easy. Can you give me the answer? Of course. A constant does not have a rate of change. The rate of change of a constant is 0. But now carefully about the left-hand side. Let's look at the first term. What is the derivative of this? Let's look at the second term. And you can say, wait a minute. It's a product. This is function 1 and this is function 2. So, plus, I don't need to put in parentheses, but I want everyone to see. Of course, I'm going to erase this. There is no room. So let me erase it now, so I don't run into it. Okay, so the first function prime times y times the second function plus times, yes, however, I would not write 1 prime. I would write, thank you. So we're done with this piece. Now I'm here. I have to subtract. Not twice, but you know it means that it continues here. What is this? Another product. Put parentheses because I don't want to have to worry about that negative sign just yet. So, the first function prime. The first function prime. 1 times the second one. Plus the first function times, now I have to be very careful, I am differentiating the function to the third power. How do I differentiate a function to a third power? Times, not yet, y squared times, indeed. Close the parenthesis and then the right-hand side now. Okay, do you think we need to do this one more time? Yeah. Very good. So the easy part is this. X is not a function, but a variable. So when I differentiate a product of 2 times a polynomial function, or power rule if you want, I bring 3 in front and I subtract 1 from the power times x prime, which is 1. So far so good? That's how we get 6x squared. Agreed? Okay, now I'm here. This is a product of 2 functions. The first function is x squared, and the second one is y. How do I know? By the fact that I'm asked to find dy over dx, it's very clear that y is a function of x. which I don't have. Okay, so then I have to use the product rule. The first function prime multiplied by the second one. It's the product rule, so I have to put plus. I copy the first function, but I differentiate the second one. Instead of writing y prime as you said, which is correct, I will write dy over dx. Any questions? Okay, then I'm here, but I have to copy the minus. So now I'm differentiating this. This is another product. The first function prime is 1 times the second function. Now plus. I copy the first function, but now I differentiate a function to the third power. So the chain rule with the power rule. So when I differentiate a function to the third, what do? I bring 3 in front. I subtract 1 from the power times, because this is a function, I cannot say y prime is 1. I have to say times the inner function prime, which is denoted by dy over dx. Any questions? Is this better? I will remove all parentheses. This is an equation. And what am I after again? What will I solve this equation for? Exactly. This is the variable I'm after. Perfect. So I copy 6x squared. There is no need for parentheses here. Plus 2xy plus x squared dy over dx. Now I have to distribute a negative sign to these two terms. So I have minus y cubed minus 3xy squared dy over dx equals 0. Are you with me? And now remember, this is what I want. Exactly. And what happens to all the other terms that do not have dy over dx? They have to go where? To the other side. The terms that do not have the variable have to go to the other side. And if anyone can open this for me, I will be. Thank you very much. Sorry about that. Thank you. Thank you. Okay, so 6x squared goes, 2xy goes, negative y cubed goes. Thank you so much. And yes, since we cannot combine these two, they are not like terms. As Joey said, factor it out. I have an x squared and I have a negative 3xy squared. This goes to the other side, it becomes positive. This goes to the other side, it becomes negative. This goes to the other side, it becomes negative. Final step, dy over dx. Can anyone dictate? Exactly. This divided by this. Now, I have to say that, and you may agree, and you may disagree. It's a free country, still. So, would I say, if I say that you feel a little bit, at least a little bit, if not more, better with algebra, would you say yes? You believe that? Okay. Right? Because we are really, the basic of all this is algebra. Adding, subtracting fractions, dividing both sides by, and so on and so forth. Okay. Let's take a look at another. Okay, let's say 25 caught my eye. y sine 2x equals x cosine 2y. Oops, it looks awful. What are we asked to determine? What do you think? Exactly. Do you want to solve this equation for y? Not in a million years. We cannot. Okay, so then what do I do? Very good. Yes, differentiate both sides. Perfect. Let's look at the left-hand side. A lot of work. This is one function. This is another function. And also the inner function of sine is 2x. So, first I have to apply the product rule. Awesome. Whatever that is, sine 2x plus times, so now I have to think. There is an exactly cosine 2x times the inner function prime. The inner function prime is 2. I reach the equal symbol. I'm not going to write this this low because when I scan, it gets cut off. So now, this is another product rule. The first function prime, so then cosine twice y, plus the first function multiplied. Now I have to be very careful. Yes, I have to differentiate cosine, and then I have to differentiate the inner function, which is, exactly, which is also a function. So perfect, in parentheses, negative sine 2y, all products except this because I'm using the product rule, multiplied by 2y prime, which is, exactly. Do we need to repeat the steps here? Yes? Very good. So let's do that again. So this is a product. So y prime is definitely dy over dx. I don't have y. Times the second function. So far so good? Plus the first function times the second function prime. If this were x, I would only have written cosine x. But this is sine of another function. This is not sine 2 times x, right? This is this. And this is this. Okay? So sine prime is cosine of the same times the inner function prime, which is 2. Is that okay? Because it's a function composition, outer, inner. When I differentiate outer, inner, I differentiate sine of the function times the inner function prime. And then I reach the equal symbol. So far, so good? Okay, now this is a product. The first function prime is 1 times the second one, plus the first function, and now I have to differentiate this. Here's what I have. The outer, which is a function, which is negative sine 2y. But now I have to differentiate this, which is 2 times a function. When I differentiate 2 times a function, prime, I get 2 times the inner function prime. Better? Okay. So this is here, and this is here. What does that mean? Nick and Joey, please. What does that mean? I would rearrange it just a little bit. Sine twice x times dy over dx. Clean it up a little bit. Plus 2y cosine 2x equals cosine 2y. And this is minus 2x sine 2y dy over dx. Now this is completely cleaned up. The variable is here, and the variable is here. Suggestions, please. Yes. So this term will be moved to the other side, and this one will be moved here. And I will factor out this. Cosine 2y minus this. Minus 2y cosine 2x. Now let's decide what we have in parentheses. Remember, this was negative, and I moved it to the left-hand side. So can anyone dictate the parentheses? So first sine 2x, but then plus 2x sine 2y. And now it's done. Yes, I divide this by this. So dy over dx equals all this cosine 2y minus 2y cosine 2x over this sine 2x plus 2x sine 2y. There are no simple examples, in my opinion, in this book. This is too long for a test or final exam. So we've seen these, we will practice them at home, but the exam and the final will have something that you don't have to struggle. It's a struggle. I mean, it's not. Also this one that we picked. This is not a problem for a test or a final exam. Maybe some extra credit or something. But it is very wise to go over this a couple of times so you can get a good grasp of the chain rule. Okay? So let's look at one more. Okay. Use implicit differentiation to find an equation of the tangent line to the curve at the given point. Okay. So this problem was given us pi over 2 comma pi over 4. And we were asked, so we didn't finish it, we were asked to find y minus y1 equals the slope times x minus x1, knowing that x1 is pi over 2 and y1 is pi over 4. Now the question is, how do I get this? I do have the derivative. All I have to do to it is exactly. And here's how we write. It's just one point. So here's how we write it. We draw a vertical bar or vertical line, and we write x equals pi over 2, y equals pi over 4, which means we have an expression for implicitly. We determine an expression of dy over dx. All we have to do now is evaluate this expression when x is pi over 2. So pi over 2 here, pi over 2 here, pi over 2 here. And when y is pi over 4, pi over 4, pi over 4, pi over 4. And then I can determine the equation of the tangent line. So dy over dx, when x is pi over 2 and y is pi over 4, let's plug it in. So not only that we can determine, although we don't have the function, we are able to determine an expression for dy over dx. But furthermore, if we are given a point, we can determine the value, which is of that derivative at that point, which is the slope of the tangent line to the graph of blah. I don't have it, of y. Okay, so cosine 2 times pi over 4 is cosine pi over 2. Minus 2 times pi over 4 is pi over 2. Cosine 2 times x, x is pi over 2, which is cosine pi. X is pi over 2 times 2 is sine pi, plus 2 times x will be pi, times sine 2 times y, which will be pi over 2. So all I did was I just plugged them in. And now I have to find these values. And the problem is done. I have to put the slope in there. How much is cosine pi over 2? Careful. Careful. Let's look at this because this is important. On the unit circle, this is an angle that is a central angle. So let's call it alpha. This piece from here till here, this piece is cosine alpha. And this piece from here is sine alpha. So if I want to determine the horizontal at this, so for an angle of pi over 2, how much is the horizontal? 0. So that's why cosine pi over 2 is 0. But how much is sine pi over 2? 1. So this is 0. How much is sine pi over 2 since we already talked about it? So this will be 1. How much is now in view of this cosine pi? Pi is right here. Cosine is measured on the x-axis. How much will that be? Correct. So this will be -1. Finally, sine pi. Yes, because this is the altitude of this point. That would be sine. So this will be 0. Okay, so what do we have at the top? What is left at the top? Pi over 2. Good. How much is this? Is 0. So this is 1 times pi. So this is pi. So I simplify by dividing those two fractions. So I have pi over 2 times 1 over pi. The slope is. So all I have to do now is replace it in here. So this is y minus pi over 4 equals 1/2 x minus pi over 2. And you can simplify it. I will distribute 1/2 x minus pi over 4, but I'm bringing positive pi over 4. After all this work, what is the slope of the tangent line to the graph of, have no idea what function is, at pi over 2 comma pi over 4? Yes, y equals 1/2 x. Any questions? Okay, I have 4 more minutes. So now, would you like to choose another function, or do I get to choose? 3.5 is not finished, only because we have not talked about the inverse, the derivatives of the inverse trig functions. Any preference? Okay, let's look at an easy one. Say it again. There was what? This is a little bit easier. Okay, so let's look at 27, which is x squared plus xy plus y squared equals 3. And they want us to determine the same thing. So this is more human. Okay, so do I want to solve for y? I could. It's quadratic. Do I want to? Absolutely not. Because if I use the quadratic formula, I'll have x under the square root. It's going to be a mess. Okay, so we're asked to find the equation of the tangent line to the graph of whatever this is at 1, 1. How do I start? I differentiate both sides. But remember, x is what? A variable. But what is y? A function. Good. So the left-hand side, please. 2x. Now I have to stop and be very careful because this is a product. Do not assume or try to do anything else. This has been invented 1,000 years ago. We can't change that. Yes. So plus 1 times y plus x dy over dx. And plus a function squared prime. Perfect. I finally reached the equal symbol. So something like this you will see on a test or final. Okay, so the right hand side is perfect. What am I after? I'm after this, and these two have to go. I cannot combine them, therefore I have to factor out the variable, which is dy over dx. I move 2x and I move y. And can anyone give us the inside? X plus 2y. Final step, dy over dx for this would be, yeah, I would recommend here the factoring out -1. It's not mandatory. It's not at all, but I think it's easier if we do that. Okay, so I would like you to finish it because I don't want to hold you. I only promised 7 minutes, so it's 7 minutes. So x equals 1, y equals 1. And find the equation. And that's the end of it.